Okay, so in this video I'll be looking at ExamCraft 2016 paper 1 question 3, and it's a complex numbers question. Solve the equation z to the power 3 minus 2z squared plus 5z plus 26 is equal to 0, given that one of the roots is an integer. Now that's interesting. Okay, to begin with, look at all the coefficients and the constant. So all the coefficients and the constants are real numbers. Therefore, if we knew a root, we could use the complex conjugate roots theorem. That is, if we knew that z is equal to a plus bi was a root, then we would also know that z is equal to a minus bi is a root. So if we had a complex number as a root, we would be able to find one of the other roots anyways, but we don't know a single root. We do know that one of them is an integer. So the fact that one of the roots is an integer is really interesting. We can use, as if it was just a normal algebra equation, we could go x cubed minus 2x squared plus 5x plus 26 is equals to 0. We could put that into our calculator and use the table function to actually find one of the roots. Now the only values that are really worth trying are factors of the constant at the end. So factors of 26 would be 1 minus 1, 2 minus 2, 13 minus 13, 26 and minus 26. And your calculator using the table function, if you have a Casio, will actually give you z is equal to minus 2 as one of the roots, but you still need to go and actually show it in the question. We're not allowed to sort of use the shortcut. We still have to do this. Okay, so we know z is equal to minus 2 is one of the roots, so that means z plus 2 is a factor. Okay, brilliant. Z plus 2 is a factor. Well, a factor should divide in evenly. Okay, also think this is a linear. It's going to divide into a cubic. A linear dividing into a cubic, you should get a quadratic out of that. Okay, so what I've done then is actually divided in the linear into the quadratic. So z by what is z cubed? Z by z squared. So we're going z squared by z squared by 2 to give us z cubed plus 2z squared. And I'm changing the signs as you can see in red. So minus 2z squared minus 2z squared is minus 4z squared. So minus 4z squared. Z by what is minus 4z squared? Z by minus 4z. And then minus 4z by 2 is minus 8z. Change the signs. We're getting down to 13z plus 26. And then that's where the plus 13 is coming from. 13 by z, 13 by 26. Dividing in to give 0 at the end. So at this point you're like, oh brilliant, give 0 at the end. I'm definitely going the right way. Just need to find the other two factors. And then the other two roots. So I know this is a factor, but it can factorize it a little bit further itself, or find the roots from it. I'm not actually going to be able to factorize this using the guide number, because I imagine if z's involved in the question, I should get complex answers. So if I'm getting complex answers, as in answers with i's, you're not going to be able to use the guide number. You're going to have to use the minus b formula. So your a, b, and c from your minus b formula, fill it in, and we're getting 4 plus 6i and 4 minus 6i all over 2, which gives us two answers. And what's interesting about them is they are conjugates of each other. So the answers are, or the factors are z minus, the roots are z is equal to minus 2, z is equal to 2 plus 3i, and z is equal to 2 minus 3i. The last question then, so there's the answers. The last question. Use the Margaret's theorem to solve z to the power 3 minus 8 is equal to 0. Well, that's z to the power 3 is equal to 8. Z is equal to the cubed root of 8. And I know a cubed root is the same as a power. Cubed root is the same as a power of a third. So when I've got a power of a third, I think general polar form. So to change it to polar form, we need to first draw out a little sketch. Or the distance from the origin is going to be 8, and the angle that's formed is 0. It's plain to see. So we're writing it in polar form. Then we're changing that to general polar form, which thinks 0 plus 2n pi is just going to be 2n pi. So normally we have an angle that's not 0, an argument that's not 0. and we'd have maybe like a third pi plus 2n pi, but no, I just have 2n pi. Then I need to apply de Moivre's theorem, which says the modulus to the power, the argument by the power. So 8 to the power of a third is 2. And remember here, how many answers should I have? I should have 3 answers, so I'm going to use n is equal to 0, 1, and 2. Okay. So here, yeah, down to that, because I've gone a third by 2n pi, is 2n pi over 3. I'm going to use n is equal to 0, 1, and 2, as I said. So here, and I think it says to leave your answer, it doesn't say to leave your answer in any form, but there's something interesting. Yeah, I'm going to highlight these 3 lines. So that's just having subbed in 0, 1, and 2 in for n here and here. Imagine what you'd get if you subbed in 0. It would just be 0 like you've gotten here. If you subbed in 1, it would just be 2 pi over 3. And if you subbed in 2, it would be 4 pi over 3. What's interesting to note about all of these answers is that they are all on the same circle. Their modulus is the same. Their modulus is 2. So 2, 2, 2, 2, minus 2, minus 2. And think of what they'd look like on a graph. The first one would be here. That's the first one. The second one would be 2 pi over 3, which would be up here. And the third one would be down here. Think of the angles between them. Think of the angles between them. The angle between them is even. Those angles are the same in each case. It's 2 pi divided by 3, or it's 360 divided by 3, which is 120 degrees. Okay, and you can see it, like, look, going from there to there, the only thing that's changed is the angle, and it's added on 2 pi over 3, and here to here, the only thing that's changed is the angle, it's added on 2 pi over 3. Alright, so not that strange at all. I've changed them both to rectangular form, or all 3 of them to rectangular form, but I don't think the question actually asks you to. But look, it's nice to, I've just multiplied it out. They're the 3 answers, but technically speaking, I suppose that could be an answer, that could be an answer, and that could be an answer, but I'd always change it to rectangular form unless they say leave it in polar form, but they don't say anything, so I've just done both. Hopefully that explains the video or the question for you.